Hi, this is Jeffrey Morgan, and I'm going to be discussing our end of semester fall 2025 soil science project, applying our lessons to a land use and soil assessment effort. We're going to be taking a look at a property in Tolland, Massachusetts that my brother in law, Patrick Hermans, recently purchased. Going to look at this from a topographical perspective, consider the soil profiles themselves, discuss field observations and soil characteristics, and then, of course, get into the use case and viability for what they're looking for, along with a final reflection. And so, Patrick purchased this property in Tolland, which is the southwesternmost town in Hampden County. It borders Connecticut along with the Berkshires. He wants to keep his daughter in her school system, and as well as looking forward to being just a mile down the road from his parents' house on Colebrook River Road. He and his girlfriend have plans to build a two-story dwelling with a full basement along with a long driveway leading up to it, and eventually have some home gardens. We're going to be considering all of this from the perspective of residential use. Because of the rural nature of the area, we do need to keep in mind use of septic and well water, along with building that dwelling with the full basement foundation. And so, as we begin, we're going to look topographically and recognize that a brook runs through the property. This is a small area of the land map there in western Hampden County in Massachusetts. Colebrook River Road goes from north to south on this boundary area to the left of the Cranberry Pond. And obviously, we can see there's a lot of topographical diversity in this area. You've got many hills, featured kind of centrally and more easterly. You can see a sand pit off to the left, and there are water bodies to be found here as well. Obviously, this is very fitting with what we experience throughout western Massachusetts with the glacially formed landscape and glacially passed and deposited till and soil. Tolland is a very rural community. There are just over 500 residents there. It is not developed, lots of undisturbed land, especially under forest cover. You can see there is some development around this pond. This is a more exclusive community called Wildwood. And we're going to look at this area just above the Cranberry Pond Brook where their land is going to be. So let's zoom in and take a look. Within this red box, we can see the general area where they are looking to build. The southerly border of it is made up by the Cranberry Pond Brook. And you can see from a topographical perspective that this is a rather ideal location because you don't have the same elevation changes as you see kind of everywhere surrounding. Not knowing what happened with the bedrock fighting the glaciers, for whatever reason, the soil here and the land is just a little more even. And we're going to see that in some pictures next. But good news on the front that they're considering is that it is a different relief. The slope is workable, and we're going to discuss what that means as we proceed forward. From the soil profile perspective, again within the red box, we can see the outline of this land and this border with the brook. They are planning to build on the northern end of this area, and so that is primarily the Tunbridge Lyman sub-series of soil. To the south, it's Lyman Tunbridge on the rest of their property. And to the north of their property area, we can see an intersection with Peru Marlowe. And that could be a good sign for them, and we'll discuss that a little more as well. So let's discuss the Tunbridge and Lyman soil types. Tunbridge was found originally or named after a place in Vermont, and so we're going to get going there. For the sake of time, I'm not going to read through these slides verbatim, but we'll highlight that there's a lot of commonality between Tunbridge and Lyman soil profiles. They are both found on glaciated uplands. They both have a good amount of drainage, the Lyman somewhat more excessively, likely due to a smaller or more shallow amount of soil from O layer down to bedrock. The Tunbridge will be a little deeper. They both form loamy soil. They are both haplorthoids. The Tunbridge being typic and the Lyman being lithic. And again, the primary differentiator there is that the Tunbridge is going to have a little more depth to bedrock. They are known for being in forested areas, having a lot of stone and rocks and mineral content. And again, they are generally considered to be found on a slope facing in the westerly direction. They both have a good soil profile that is observable, and we'll see some pictures of that coming soon. Definitely a healthy O layer, and then the presence of either an OA or an A layer soon thereafter. They both have that E layer that you can find in a pine forest, and then varying B levels of horizon above the bedrock. These soils are really found in the northeastern United States, and again, a key feature that is worth reemphasizing is that they will both be expected to have a prominent amount of rock fragments, definitely owing to that glacial till and glacial formation of these soils. And so we went out to the property on December 7th, 2025. Patrick and his girlfriend are on the right. My wife is on the left. I went out digging the holes as they did some other work on the land. And so I used a feature in the Apple camera to give me reference to be sure that I was taking a level photograph. So these photos are doing the work of showing us the hill or the slope going up ahead of us with my back at the roadside. And so this is facing to the east, and we can see this gradual slope going up. It's not too significant, but it is recognizable and observable with the naked eye. And additionally, as we move along the property, that stays consistent in the photo on the left, and then in the photo on the right, as we made our way to the more south side of the property, we can see this ridge kind of dropping off, and below that is where you can find the Cranberry Pond Brook. I did my best to dig 3 different holes to get varying soil samples spread out in the area where their foundation and or gardens would be, and did my best to capture these images. I don't feel like the pictures did the colors justice. Just as I was starting to take the photographs, the sun kind of went behind the clouds, and it took away what I could see with the naked eye. But in these pictures, we've got a very nice view. I went about a foot down and could see this very clear O horizon on top, followed with the A horizon. We'll see in the next pictures even better differentiated, the E horizon, but you can see it here on the left, this gray strip. And then on the right, again, this gray layer showing that anticipated E horizon, and then some nice hues coming through for the B horizons. We're seeing some orange, red, yellow blend there looking at that lower soil profile. I really liked this picture on the left. We can see this gray E horizon below the O horizon. Obviously, because this is undisturbed land, there's a ton of root systems here. And then deeper into the hole, we can see that more developed soil profile going deeper. I like this picture on the right as well because it really illustrates this thick layer on the top of the soil profile here with this O horizon. With one of my holes on the left, I was able to capture some of this soil and kind of keep it intact as it came out of the hole. And so we can see again the brightness of these colors, a really nice profile. And you can even see that soil as it came out of the ground retained that crumb structure. Very friable, very nice, healthy looking soil. And on the right, again, just from an observational perspective, I was really impressed. As I was starting one of the holes, I tried to kind of dig around the top, and I ended up pulling off this top layer that was almost like pulling off the top of the cake, where we had this really significant litter layer or O horizon. You can almost make out the humus, the dark material here, and you can as well see that gray layer. I got really lucky with this this little beginning of this hole and this photo. So just obviously these soil pictures, while imperfect and not necessarily very scientific, do illustrate that we are seeing the general horizon pattern that we would anticipate based on what the soil surveys tell us we would find here. Bringing these into the lab, I was able to test these. We just did the basic nitrogen, phosphorus, and potassium testing. The nitrogen, I was happy to see, is existent there. It's on the low end, but that's still, I'd say, a good sign. Not surprising due to the healthy biome of this area, to be in this forested area with a lot of organic life and organic material. It's not surprising that there is still nitrogen present, despite the fact that it washes away so quickly with infiltration and percolation. Additionally, from both the phosphorus and the potassium perspectives, we had a medium amount of phosphorus and a high amount of potassium. Once again, definitely indicative of just this very healthy soil in this very healthy biome. Additional observations that I'd like to offer in this moment are just that while in the field digging these holes, I was seeing in the earth, under the insulating layer of the snow and the insulating layer of the litter layer, I found earthworms still at it, still active. I found grubs, which aren't good for the lawn, but are doing their job in the soil. Just very healthy soil biome. And then under the microscope in the lab setting, I couldn't capture the photo, but again, just a great variety of soil textures and colors, the evidence of the litter layer, and even I was seeing springtails, that white to clear soil organism. I saw them still moving around several days later after digging my holes. And so, use case and viability. This is really what this is all about. I chose these pictures. These were captured the day we were there, December 7th. On the left, we can see how Patrick is starting to clear an area for his driveway to come off the road, which is viewable on the left. And I added the picture on the right because those stones are what have come out of the ground already, just in clearing the area on the left. So there are some trees and stumps that have come out already, and those stones are just from clearing that space on the left, which is definite foreshadowing of what is to come. These three map images indicate that the soil profiles, the Tunbridge Lyman on the top and the Lyman Tunbridge on the southerly end, are very limited for residential use cases. These three images depict building a dwelling with a basement foundation, using septic in that area, and concrete corrosion and the impact of soil acidity. So they are in an interesting situation, and that's what we're going to discuss from here forward. So with very limited use, that is at the bottom of the spectrum or range of what would be recommended just using soil data for moving forward in this way. There would likely be significant mitigations required to proceed. The soil depth to bedrock could be a limiting factor, and depending on which soil profile kind of makes up the majority there, that's going to be very telling. Additionally, the high acidity may require some protection of the foundation, as well as potentially even the importance of putting some lime or something to regulate that acidity before concrete goes into the ground. And then the septic, while they did have good percolation tests, there is the reality that a tank will need to be buried and the field will need to be set out. And so depending on the depth, they may need to raise those items. But Patrick finds himself in an interesting position because he is a construction foreman. He not only has many years of experience working in the ground in various capacities, from road building to culverts to drainage and beyond, but he also has access to a lot of that machinery and the tools. And so the combination of his experience plus the machinery and tools plus time could afford him the opportunity to work through what for the average person may become an unaffordable project due to how much digging, rock removal, blasting, and or other mitigations necessary to get this foundation into the earth and to prepare the soil and put septic in. On the other hand, they do have the anecdotal experience from a mile north that their parents went through when they built new, and they were able to put a beautiful home up. It's a single-story home, but it has a full basement at significant depth, a very significant ceiling in that basement. And they did encounter the stones, and their yard is still full of them as they've used them to create boundaries for gardens and property lines and whatnot. Patrick did send me this image where he took the backhoe to dig a test hole in the area where he knew the foundation would be at least a little. They still are looking for an easement to try to be a little closer to the brook, but this was a safe initial hole for him to dig, and he didn't run into major boulders or stones. But just like the soil map says itself, the smaller the sample, as we're looking at, the less accurate it's going to be. So just like we can't make major assumptions about the soil we're viewing based on the map, because the map areas were looked at in a more broad perspective, this hole isn't giving us an indicative sample of what's to come beyond this specific area. It does still give us a great view of the soil profile. And while I wasn't there, it looks like it might have something finer, maybe even a clay on the bottom. It's a good initial outcome, but definitely not a forecast. One hypothesis I do have relative to all of this is the presence of that Peru Marlow. The photo on the left shows us that boundary with Peru Marlow that extends from the property to the north of where they're going to be. And on the right, I've got an image of the area where the location marker is showing where his parents are. And his parents are in an area with the Peru Marlow, which could be indicative of kind of a good blend of what Patrick and his girlfriend may experience as they take on this effort. The big difference is with the Peru Marlow, it's obviously still very typical New England, Western Massachusetts glacial till. The soil profile is a little more of a sandy loam lodgement till. The depth to bedrock is a little deeper, more in the 5-foot range. This proximity could be a good sign, and it definitely gives them something to be hopeful about. And as I said, they did find that significant stone presence in that other property area. And so while it is anecdotal, it is something that they feel a little assurance about. And so, taking all things into consideration, this soil profile isn't necessarily the best for residential development. Using the rating strictly would not point anyone toward doing this blindly. However, because of his known experience of his parents up the road, as well as there being neighbors right on this street and people throughout the Tolland area, while it is not densely settled, there is obviously proof that it is possible to work this land to build a home and make use of it. And again, Patrick finds himself in a very unique situation where he can use his expertise and the equipment and machinery available to him to potentially overcome the burdens. A good concluding thought is really just that, as I mentioned in my writing on this project, having this information is going to be good from a preparatory perspective for Patrick and his girlfriend, and it may also give them some much needed clear information that could point them in the right direction if they find they can't build. And it is something that they need to potentially walk away from or make a different land use out of. So having the information, learning in this soil science class definitely affords myself and them a great deal of knowledge to make an informed decision. I hope this has been informative, and I thank you for your time.